All of us are anchored to the earth by gravity. We have no wings with which to fly. I wish I could fly. I wonder what the edge of the sky looks like. Most children have such fantasies. Let's set those dreams, those longings skyward, by allowing children to build and launch their own water rockets.
皆さんこんにちは。
Hello
この
everyone.
教材では
This instructional video targeting teachers and instructors will provide you with basic approaches and tips for making and launching water rockets. Water rockets are easy to make and use materials found in daily life. Children will be thrilled and their creativity stimulated watching their handmade rockets take to the sky. Rockets that perform well have good science behind them. So it is essential that you understand the basics of water rockets. I'd like you to enjoy watching this video before building safe and high-performance water rockets with your students. Now, how about I explain how to make a water rocket? What materials should we use? The water rocket consists of three basic parts: the body, the head or nose cone, and the tail, which includes fins. We use PET bottles to make the body and the head. Every rocket requires 2 PET bottles, specifically bottles used for carbonated beverages. We will use one of the bottles for the rocket's body. The other bottle we will cut apart and use to fashion the head or nose cone. PET bottles used for mineral water, tea and other non-carbonated soft drinks are available, but they are weaker than carbonated drink PET bottles and therefore unsuitable for water rockets. There are also square-shaped bottles. We don't use these because air pressure will cause them to deform. Please keep these points in mind. So get yourself some carbonated drink PET bottles, empty and rinse and dry them, and peel off their labels. If you have trouble removing the label, you can use a cutter to scrape it away. Avoid damaging the bottle's body when using the cutter. You need 2 flawless carbonated drink PET bottles. Check them over before putting them to use. We now have our materials for the rocket body, which will generate the thrust for the water rocket. Next, we need tail fins. These will allow the rocket to achieve high, stable flight. For the fins, we will use moderately hard PVC sheets. You can find them at your local do-it-yourself outlet. To achieve maximum stability, you're advised to position the fins as far back from the body as possible. This calls for a cylindrical tail section, which you see here. To make the aft cylindrical section, we use a soft plastic material, such as that used for plastic folders. To make the cylinder, we'll take scissors to a clear file sheet and then attach 4 fins to it. Another key point to ensure stable flight is to make the rocket's front end heavy. We'll use modelling clay as ballast. We'll attach a piece of clay to the front of the rocket to make it heavier. 50 grams of clay will be sufficient. In addition, we will use a large-sized trash bag to reduce damage to the rocket when it returns to Earth. Attached to the nose cone, the trash bag acts as a cushion, absorbing the impact. Finally, we will need a nozzle. The nozzle connects the rocket to the launcher. Placing it securely on the launch pad is important to ensure a successful launch. While you can replace the nozzle with readily available articles such as a bicycle tyre valve or a rubber stopper, we will use a ready-made nozzle as a safety precaution. The nozzle will be attached to the PET bottle's mouth, like so. All of the materials needed to build a rocket have been assembled. You'll also need a pair of scissors, some vinyl tape, a magic marker, ruler and a cutter. The use of plywood or a cutting mat is recommended, as they will protect your workspace and desk from damage by the scissors and cutter. Let's now have a look at the water rocket building process. First, measure out the 4 fins on a PVC sheet. Use a ruler and a magic marker. Next, cut out the fins. You can use a cutter, but a pair of scissors would be safer. Now, divide the base of each fin into 4 equal parts. Make 3 cuts at intervals of 2.5 centimetres. Here again, remember to mark the cuts beforehand. Alternately, bend the 4 parts to the left and the right. You can bend them straight, neatly and easily by aligning the ruler with the line like this. With the 4 tail fins ready, let's make the aft cylinder or skirt to which the fins will be attached. First, cut the clear file at the joint to spread it open. Then, cut it into halves along the vertical centre line. You can use a cutter, but a pair of scissors would be safer. Wrap one of the sheets around the PET bottle and adjust the length of the cylindrical section until it's snug. Wrap the sheet around the bottle's fall section and adjust its length so that the cylinder protrudes slightly. Now, let's attach the fins to the cylinder. The fins must be attached to the rocket body at right angles and at intervals of 90 degrees. This means you must divide the circumference into 4 equal parts. Once again, wrap the film cylinder around the PET bottle and mark the circumference. Then, divide the circumference into 4 equal parts. It is now possible to fit the water rocket with the fins at intervals of 90 degrees. Draw a 10 centimetre guideline from each of the marks on the cylinder and then cut along the guidelines. Each fin is to be inserted into a cut. Each cut, therefore, must be straight. A crooked cut will lead to the fins being out of alignment. Insert the fins one by one into the cuts this way. Then, tape the slots securely from the reverse side of the film. The cylinder, complete with the 4 fins, is now ready. Next, we'll wrap the cylinder around the rocket body. You can wrap it neatly by fastening the starting edge of the cylinder with vinyl tape to prevent it from slipping out of place. Use more tape to securely fix the cylinder at its leading edge. Remember to position the fin section so that it protrudes slightly relative to the bottle's mouth. This will allow the rocket to be set properly on the launcher. Now, we will cut the other PET bottle along 2 guidelines. In this video, we are using an opaque white bottle so that the 2 lines show up clearly. As it is a bit difficult to pierce the bottle with the pointed tip of the scissors, we will make our initial cuts with a cutter. Be careful when handling the cutter because the bottle's surface is very slippery. Cut the line that is closer to the bottle's mouth. Then, do the same for the second line. Scissor off the part near the bottle's mouth first. Next, cut the nose cone from the bottle's body. Scissors for use with PET bottles are available. We recommend you use this type. Here's the part of the bottle we've just cut off. It will serve as the core structure of the nose cone. Next, we'll proceed to adjustment of the water rocket's balance. Using modelling clay, apply a sizable lump of clay to the front end of the bottle proper. Please make sure the clay is applied evenly to prevent the rocket from listing to one side or the other. Test the rocket's balance by placing it on your finger like so. The centre of gravity should be closer to the nose cone to ensure a well-balanced flight. Push the nose cone over the water rocket and tape it securely into place. The rocket is nearly complete. The final step is to use the vinyl bag to fill the empty space in the nose cone to create a cushion against the impact the rocket will absorb when returning to Earth. Use vinyl tape to keep the bag securely inside the nose cone. In order to launch the rocket, we need to fit this PET bottle with a nozzle. Screw the nozzle onto the PET bottle. Make sure the nozzle's opening protrudes beyond the tail fin cylinder. The water rocket has now been completed. Although our rocket looks like this, your students can choose whatever colours they like. They can even draw pictures on their rockets. The idea is to enhance their enjoyment by allowing them to make their own original rockets. For junior high and high school students, you might challenge them with a series of questions. For example, how will the rocket fly if fin sizes are changed? How will it fly if they change the weight of the nose cone's ballast clay? Next, let's proceed to an explanation about the launcher. We need a nozzle like this to launch the water rocket. First, screw it onto the rocket's mouth this way. Then set this launch gear as shown here. After pumping air into it, the rocket will be ready for launch. The launcher is used to set the direction of the rocket's flight. For this demonstration, we've made one like this. Here we used 4 pieces of wood to hold and guide the rocket. With the launcher set accurately to the desired angle, insert the water rocket into the space between the supports. Then attach the launch gear to the tail. Since our launcher is made of wood, we've coated it to protect the wood from water damage. This launcher is designed to be adjustable. The angle of launch can be modified as desired. If you have access to a wide open area, it would be safer to launch the rocket at an angle as shown here. Otherwise, you can launch it straight upward. Various other types of launcher are possible. A common type, for example, is this one using steel pipe. With this launcher, we attach a piece of PVC pipe to the rocket body and run the steel pipe through it like this. Attach the launch gear and you are ready to go. The water rocket is now ready for launch. Here are some points you need to consider when selecting a launch site. Water rockets can fly a distance of about 50 metres on average and as far as 100 metres if conditions are favourable. The site must be at least 50 metres long and wide enough to accommodate a rocket that has deviated from its intended course. It will also be better if the site is where you can discharge water without disturbing others. If your intended site is